Many of you have probably been to some of my webinars before. I've given webinars on a number of different topics, including signal processing, electrical power systems engineering, and new releases of Maple. At least for me, this is probably the webinar I've anticipated giving the most over the last few years. In what follows, I'm going to assume that I'm speaking to engineers. However, if you're not an engineer, the arguments and concepts still apply to you, but I'm going to frame whatever I'm going to say in terms of engineering and an engineering audience. We're going to look at a new calculation tool we've just released called MapleFlow. MapleFlow sits alongside Maple as our tools for engineering mathematics. Both products have some overlap. As you'd hope, in both tools, 1 + 1 = 2. But they both have very different design principles and a different target audience. We'll talk about the positioning later and why you choose one tool over another. I want to briefly show you the tool first. After that, I'll jump into some slides and I'll talk about MapleFlow, its positioning, its features. And at the end, we'll spend more time in the product. And as Rochelle said, at the very end of this webinar, we'll have time for questions. So, as I said, I want to briefly show you the tool first. So I already have MapleFlow open. This is what MapleFlow's home screen looks like. I'm going to load up one of the standard applications that we bundle with MapleFlow from the application gallery. This will be a growing resource of in-product applications, so there'll be more added in coming versions, and I think I'll start with this one. Again, I'm not going to go too deeply into the details. I'm just going to talk about some of the principles involved. So what do we see on screen? Looks like we see some text at the very top. We see a diagram, and then I have some equations and some parameter definitions. So everything you see here is a container. So this title is a container. I can move this about on screen. This image is a container as well, so I can move that about and place it on my screen. All of my equations are in containers as well, so I could move this down here. I can move my equations about. If I scroll down, if you're particularly eagle-eyed, you'll see some references to functions. So this is fsolve. This is a Maple language function for solving an equation or a group of equations numerically. And here I have a plot generated with the polar plot command from the Maple plots package. If I change a parameter, so let's change this again, that change cascades automatically down my MapleFlow worksheet and all of the results, dependencies, plots, update to reflect the new parameter value. Now we'll look briefly, we'll look at the product in more detail later, but as I said, everything is a container. If I wanted to, I could click at any random point in my document and just start typing some math, doing some analysis, and so on. Let's return to these slides and let's talk about MapleFlow in greater detail. We'll talk about some of its features and how it's positioned alongside Maple. So MapleFlow is a tool that we've developed with the needs of design engineers in mind. MapleFlow has a simple freeform interface that feels like you're using paper. Doesn't feel like a word processing tool. It doesn't feel like you're using a programming language. Feels like you're using paper. You can use it for calculations and documentation. And it's targeted towards design engineers. And I'll talk later what I mean by design engineers. So these are some of its features. You can place math, text, images, and plots anywhere on your canvas. A canvas is what we call a MapleFlow worksheet. It speaks to the freeform nature of the interface. MapleFlow evaluates left to right, top to bottom. So it reads very much like a page from a book. Your worksheet updates automatically as soon as you make a change, so your results are never stale, they're always up to date. It has built-in support for units. You enter your equations in natural math notation. And there's a very broad, very deep math library based upon the Maple programming language, with a few tweaks, with a few differences, but it is based upon the Maple programming language. With MapleFlow, you can design a calculation document, a canvas, exactly how it'll seem when you print it out, either in PDF or hard copy. So this is the worksheet I showed you earlier, and this is what it looks like when you export it to a PDF from the product itself. So it's a faithful reproduction of what you see inside the interface. So MapleFlow has a simple freeform interface. And one metaphor I keep on using is that it does feel like you're using paper, but paper with a math engine under the hood. It's fluid and intuitive to navigate. You can move elements such as equations, images, and plots around your canvas with your mouse or even the keyboard. I like to think that we've engineered in ease of use. You can use it occasionally or frequently. You could use it intensively for a couple of weeks at a time, or you could come back to it after a few months of doing something else and it still feels natural to use. Because of the forward in space evaluation model, because your worksheet updates automatically, and because there's native support for units, it means that you can spot errors quickly and easily. There's also a growing library of in-product applications and demonstrations as well. So what does this mean for users, the people actually using MapleFlow to solve technical problems? Well, I like to think that you don't have to start with a grand plan in mind when you first start using MapleFlow. Most people, when they start solving a problem, they don't have all of the steps planned out in computational detail. They try a few things, they write down a few equations, they evaluate them, they make some changes, they update their analysis, they might change the format of their equations, they have some results on screen. The very nature of MapleFlow, the freeform layout, means that progressive refinement is encouraged. You're not penalized for making mistakes or making slight errors. Ultimately, this means that there's a smooth transition from your initial prototypes, your initial calculations, to a final technical report. You just make small baby steps along the way, and everything feels natural. As I've mentioned earlier, MapleFlow sits alongside Maple as our tools for engineering mathematics. There's some computational overlap in between the two. In both tools, 1 + 1 = 2. In both tools, you can do some level of symbolic and numeric mathematics, but they both have very different design intents. We envisage Maple as our tool for researching engineering mathematics. If you've ever used Maple before, you know that it has a word processor-like environment for math and documentation. And it's ideal for mathematically oriented work. If you're deriving equations, if you're doing a lot of programming, if you're doing a lot of symbolic manipulation, Maple is the right tool for you. However, there's a whole tranche of engineers whose mathematical needs are rather more prosaic. You might be a structural engineer creating a simple design report for reinforced concrete design, or you might be a subsea engineer designing an undersea pipeline. Your mathematical needs are rather more simpler. And in that case, MapleFlow is the right tool for you. It has a paper-like environment. You can write calculations and text anywhere. And it's really designed as a daily driver for your simple, regular calculations. You could even consider it as a replacement for anything you typically do in a spreadsheet. So right now, what I'd like to do is jump back into the product and show you a few things from scratch. And we're going to start off by firing up a new canvas. So this is your canvas. This is where you do all of your math, your documentation. There's a grid cursor. I can expand some palettes on the left-hand side. And there's also a context panel on the right-hand side, which will let me rescale units, apply numeric formatting, and so on. Let me just close those down. So we're just left with the canvas. MapleFlow has a tabbed interface so you can rapidly switch between different applications. I can move my grid cursor about with my mouse just by clicking, or I can move the grid cursor about with my arrow keys. So I'm simply using the arrow keys on my keyboard to move the grid cursor around. At any point, I can start typing and doing some math. There are some computational differences with Maple. I won't go into those in any great detail, but hopefully they'll become apparent as I progress through this demonstration. So here I've just written a couple of calculations. I can move these about on screen with my keyboard and with the mouse as well. I can also write text at any point and move that into position. I can also define variables and use those in my analyses. If I change parameter values, those changes cascade immediately down the length of my MapleFlow document, the canvas, and all of the results and dependencies update to reflect the new parameter values. MapleFlow evaluates from left to right, top to bottom. So if I take this equation and move it to this point, well, it doesn't know what the values of x and y are anymore. So that's return unevaluated. Move it to this point. Well, it knows what the value of x is. Move it to this point. It knows what the value of y is now as well. I can also create plots at any point using Maple language commands. expand their size, move them about into position. I can also insert images. So at this point, I'm just going to open up a document that I'm halfway through developing. And we're going to expand on some of those ideas and see if we can do something with this. So I've already got some Maple language commands up on screen. Looks like I've defined some parameters. I have some equations with units associated with them. Units are an important part of Maple Flow. So for example, I can add 3 feet, 4 meters. Maple Flow does all the unit conversion for me. If I want to, I can rescale the result to my own chosen unit. So let's say inches. Maple Flow handles all the unit conversion. I'm going to start by moving everything down. All of this uses simple keystrokes, and I'm going to insert an image. And let's move that into position. And I'll add a title. Let's add some formatting as well. Well, if I scroll down to the bottom, what I want to do now is add an equation and do some analysis on it. So I'm going to click at that point and define a pressure balance equation. So all of these, well, most of these parameters have already been defined in my document. And now I'm going to use a Maple language function to solve my equations. So this is an equation that I'd already defined. And this is my new equation. I'm going to add some initial points for the numerical solvers. It looks like I've made a mistake. That should be pressure balance, and I'll use command completion to correct that. There we go. So Maple Flow has solved these two equations iteratively to give me the unknown values. At this point, what I could do is select View Print Extents, and that places this on screen. These are horizontal and vertical dashed lines which delineate the boundaries of my printed page. Everything will be printed out exactly as you see it on screen. Looks like there's some overlap here. So I could move this into position, format the text and make it smaller. Looks like I've got a density here. I've entered in that density manually, but what I could do instead is extract that density from Maple's computable database of fluid properties. So there I've extracted the density of water at a temperature of 294 Kelvin and a pressure of 1 bar. and the computed value of density is there. If I wanted to generalize this even further, I could define a fluid called water and replace that reference there with this name, fluid. So now, if I wanted to, I could change the fluid to ethanol, and my computed viscosities, densities update or reflect the new values, and those changes are automatically reflected in my results at the very bottom. So as you can see, MapleFlow is great at doing this type of quick, iterative scratchpad work where you're trying things out, where you're experimenting with mathematics, where you're interactively computing. And once I'm happy with my document, I could refine the formatting, refine the layout, move images around, add explanatory notes, and so on. And once I've created my complete document, I could export this to a PDF. So typically, I see many design engineers who want to create documents or calculation worksheets like this, which have a title page or some kind of calculation header, diagrams, images, and everything is formatted for print. And this is the type of work that you can easily do in MapleFlow. So this header block is simply an image, but what I can do with Maple's drawing toolbar is add text to the header block, change items, move that text into position, and so on. Once I've done this, I can export this to a PDF that I can hand off to a client or a colleague. There's one more detail I want to cover, and this may be relevant for those of you who are already familiar with Maple. MapleFlow uses the Maple programming language, so you can use nearly all of Maple's programming packages and commands within Maple, but we have made a few computational changes in order to make MapleFlow more amenable for design engineers. So for example, rationals are automatically converted or evaluated into floating point numbers. Pi, by default, is just a floating point approximation of pi. By default, everything is defined, formatted to 3 decimal places. Of course, there's more decimal places under the hood, so you're assured of some accuracy. So we do more numeric evaluation by default than in Maple. However, there may be applications in which you want to prevent numeric evaluation. In that case, you can actually set a numeric or symbolic flag on that math container. By default, all math containers are given a numeric flag, but you can actually click this button and give it a symbolic flag. And this is the result that you would typically see in Maple for the same computation by default. So that was everything I wanted to talk about today. There's far more information on our website, and I do encourage you to go there if you want to see a demonstration video, learn more about the product, and see how it's differentiated with respect to Mapleflow.